Hello. Hi, everyone. Thank you for coming to this talk. I hope you enjoyed the convention. And yeah, let's get it going. My name is Antonio Lattanzio. I've been working in the game industry for a bit of time, almost 30 years. And I work for Blind Squirrel Games. And I work for Gameloft, Avalanche Studios in Stockholm, Chrome Studios in Brisbane. And shipped about 20 titles and more than 40 not shipped. So sometimes something goes wrong. This about quick introduction about Blind Squirrel. They has been founded in 2010, shipped 58 titles, location Auckland, Irvine, Austin, and we is a studio focused on code development, AAA games, porting, and on original or licensed games. So, about this talk, this is the agenda. I'm going to talk a bit of motivation about why I'm doing this, why I started to do destruction different from what chaos does, and anyone here do you guys know what is chaos? Chaos, okay. All right, that's good. And then what we can do apart from using chaos and physics, and we will do a bit of deep dive, then takeaways. Okay, it's better if I go faster because there is a lot of stuff here. Okay, motivation. The reason why I started to do this is kind of a bit of personal. Reached a stage where I got so many personal problems, rejections, or made me feel demotivated to do a lot of things, and people telling me, no, this is not possible, this is impossible, made me so angry that I decided, you know what, I want to create something where we can destroy everything. That's the real reason, and I'm serious about that. And why about destruction? Why that matters? Because in a game environment, you want to be free to go around and destroy some stuff because, I don't know, you don't like it, or maybe you want to do something different. You want to be free to do whatever you want, which is the reason why gave me so much motivation. And we also know cinematic is different than gameplay destruction. And yeah, the goal has always been to be responsive, procedural, real time. So talking about motivation, there is a very simple couple of screenshots from Houdini. We can see clearly what happens in Houdini. We get a cube, we do pre-calculation, geometry collection, and then we can disassemble and make the cube explode using maybe force fields, like in chaos. But what happens? Why I cannot break that, make a hole in that brick? No, it made me so angry that I wanted to find the solution to do it. And yeah, and no one could find an explanation. So that's my motivation. Why not? Why? Okay. Sorry, I'm trying to be funny, but actually it's been a really annoying me so much because and became very serious. Yeah. So, going forward, my objective in this talk is to make a hole specifically in that point. And I want that hole to be any size I want. So, the problem here is that chaos is awesome. It's one of the best physics engines ever made, to be honest. It's visually impressive. It's got so many options, so many features. It's very easy to prepare your geometry collections. But when it gets to gameplay, if you want to destroy everything, it's pretty much impossible because you cannot destroy a huge terrain 4 by 4 kilometers. What are you going to do about that? You're going to pre-bake all those geometry collection. They're going to be millions. So The key message here is that destruction in cinematics is different from gameplay, cannot be the same. And because chaos was created in a time when they were switching from physics to chaos, they were aiming mainly to a cinematic simulation to make things look very cool. So in this, my proposal, my idea was to create a hybrid system which allows immediate player response, lightweight procedural debris, and dynamic terrain and crack generation. Yeah. So let's get about chaos. I will do a quick introduction about chaos because I don't think there will be much time yet. So chaos is, before chaos we had physics, apex, and we will talk about what chaos does well, where chaos falls short. So before, in Unreal 4, if any one of you remember, there was physics. Physics was developed by NVIDIA and has been there for a very long time. It's been adopted by a lot of different engines. And physics has always been amazing because we could create a pre-fracture meshes, Voronoi patterns, where everything included in a single library. So yeah, the limitation for using physics in Unreal Engine, there were, well, apart from the fact the same problem with prefactoring is that the main issue was that physics has been always a middleware, has been always a library pre-built, never been a open source till recently. I don't know if many of you know, but physics became totally open source just recently. I think it was in April this year. So they even released all the source code for CUDA and GPU acceleration. So before chaos, Epic decided to create a solution where they could handle the source code, and so they could create a multi-platform engine built for different platforms, no problems to ask for updates to NVIDIA, to be totally independent. So in Unreal 4.23, chaos was introduced, and everything was broken, obviously. And so there were a lot of patches, updates, and yeah, in the end, we got a chaos today, chaos physics, and we have a lot of really cool features, like very similar to physics. So I'm going to show you a screenshot how it looks like this, the editor. Most of you probably already know that. Is we open the editor, we just drop a simple cube, and then we can prefactor it using Voronoi patterns. And yeah, chaos has got a really nice fracture system, is very amazing. And but again, is requires a lot of work because we have to create those static meshes, then put in collection, and then we can use them. I can show you here a video. Can we please play the video? In this video, we can see the how physics is used, and we can see that the result is very excellent. We can make holes everywhere, but if you look very carefully, those holes are all pre-baked. That's the has been always annoying me, but also you can see those blocks. They are the same mesh. Same pre-baked structure, so they use the same geometry collection. You can see there is a cut in the middle because it's just a block like that. And so yeah, we create the fracture system. We put all those geometry collection together, and from this screenshot you can see how many chunks of geometry are generated by a single cube. In this one, just a single cube is 20, and they need to be stored, and they will take memory, and imagine putting like 1,000 of those with different shapes. It's going to increase a lot of memory usage. And what if we want to break those small bricks in smaller? It's going to increase exponentially. In this case, it's going to become 20 plus 34, 144 piece of geometry for a single block. If you want to know more about chaos, feel free to go on the Unreal Engine website, and yeah, you can find all the documentation there. There are really great tutorials. It's very, very informative and very useful. And you can put your doors or columns or rocks breaking in your game very, very easily. I recommend that if you have that in mind. So let's go ahead and talk about hybrid design. So my philosophy has been use chaos where it shines, but override where it fails. The realism needs to be balanced with a gameplay. Unfortunately, we cannot have an amazing destruction if we do procedurally, but the result could be interesting. Let's see why. For instance, we have a gameplay event, then runtime system will trigger chaos and a custom simulation. If you use chaos, you might remember that it's like you just apply force fields, and then you can break any structure, or the structure you can put anchor points, and the anchor points can be attached to other anchor points. So in the end, you can build huge buildings. And in this video, I'm going to show you a prototype of the destruction system I've been implementing when I got angry. And I put some labubus, as you can see. And yeah, can we play the video, please? You can see that is just the basic template of Unreal 5. And yeah, the static mesh doesn't get any damage. This one gets damage. And you can see, apart the texture that are wrong, you can see that everything gets broken in real time. The cool thing about this is that nothing is pre-baked. It's all happening in real time. You can see that there was a bit of a slowdown because it's not fully optimized yet. In the next, in this demo, we show this system. This was a note about the demo, sorry. Determinism and physics. Everyone knows that chaos has a small problem that everything is not deterministic. So we also need to resolve that problem. And doing a custom procedural system, by using the same data, we can create exactly the same destruction on a different client if we plan to use multiplayer. So the advantage of using the hybrid approach. So using this system, we have design control, performance improvements, scalable to large environments. Is very easy to maintain. Just imagine your artist create a wall instead of putting on chaos and pre-calculate and save and everything. You just right-click and say make this destructible, and just works. That's the idea. And now I have a question for all of you. Based on your experience, how would you handle a very large-scale destruction in a game based on our current technology? Do you have any idea? Well, you don't have to answer. I'm just teasing you because we know that it's not really easy. It's not impossible, but it's not easy. And I want to give you an example. If anyone knows this game, this was one of the masterpieces called Red Faction. This is the first Red Faction. This is 2001. Can you imagine? In 2001, we had an engine where you could break everything. Why we don't have it today? 24 years ago was already possible. And then after that, we had a new version of Red Faction where they improved the destruction with a structural damage. And you should play this game, it's awesome, man. You can go around, you have mission, you go around, if you decide that you see a house, you don't like it, go there and you destroy it. And it's so cool, really. And yeah, talking about other games, everyone probably already saw a video of Battlefield 6. I don't know, I'm not sure what you think about the destruction. I think, personally think that is amazing. They managed to do a really a realistic and a very satisfying destruction. But at the same time, I will be a bit concerned about the game design, because there will be some of the destruction seems to be pre-made and could cause a lot of other complaints. But still, it's going to be an awesome game. And then after Battlefield, I don't know if you guys read this tweet. We had a lead from DICE that was saying that Unreal Engine cannot do the destruction because it's a generic engine. Yeah, to be honest, I agree with that. It's very generic. Unreal is not that amazing, but yeah. Then I gotta say, I was gonna make a joke about this, but then we got like team said, okay, let's call it generic engine 5. Why not? Then and this caused a lot of hilarious posting. Obviously, I was trying to be sarcastic. Unreal Engine is not a generic engine. Is a sandbox in the end. We can do whatever we want for real. I still don't know why a lot of developers, they still don't understand the power of this engine. And talking about other games, you surely saw other games like the Finals. Recently, they released a new season, and they confirmed that they are using Unreal Engine 5, and they replaced the chaos with physics. Everyone has been saying that was not possible, but they did it. So it is possible. That made me even more angry. Yeah. So yeah, we can showcase a bit of the Finals here if you haven't seen that yet. They have, based on the red faction that I was talking before, we can see the structural damage, how nice and satisfying is. This is Unreal Engine modified with a physics. And yeah, we can skip to maybe to show the tower. Oh yeah, I think it's gonna be now. You can see they created a system where you have those structures exactly like in Red Faction, where each point has their health, his own health, and based on that, we can destroy everything and do whatever we want. There are so many crazy destruction happening in this game that has been increasing the gameplay and the engagement so much. Yeah, you can see that you can just destroy buildings so easy. Yeah, maybe if you can please skip to the last bit so I can show you. Yeah, I wanted to show this one because they don't just destroy the building, they use the destruction for gameplay, which is very similar to Battlefield. But the only difference is that this is not pre-calculated, this is all real time. You can see the building is collapsing, and there are players inside that they're still shooting. So you can imagine they are in a first person, they're gonna be falling. So, yeah. Yes, please, and we can put this one now. Yeah, thank you. And yeah, talking about physics, you guys should really go and have a look. If you are a C++ programmer, you're gonna love this library. It is so clean, so perfect in each part. I'm not saying that Chaos is not great. It's amazing. But this one is all C++. You can build it by yourself, and you can create tests. So I was wondering how those guys, they made it, how the Finals, they did it. So just before coming here, I did a bit of a test, and I managed to do another build with my test case with a Labubus here, and I created a plugin that, yeah, can you please play the video? A plugin that runs physics inside Unreal Engine 5. They said it was not possible. That was the reason why I tried. And So I created this simple plugin. You can see that I just added to my plugins list. Yeah, it's already enabled. Yeah, it's a one-day work, so I didn't even bother to put a proper name or icon. So, and I included the library, and I created some blueprints nodes, and then we can get a init physics, and then I create. Yeah, you can see the source code here for other technical. Other programmers, you can see that it is calling actually the function that goes in the physics SDK and is actually calling the real implementation from NVIDIA. You can see that everything is possible in Unreal. It's not true that you are forced to use only their own engine. If you want to, you can modify whatever you want, and that's exactly what they want from us. You can see here there is like all the source codes. We can even build it. I don't know. I think I tried to build, but I skipped that. And yeah, and if we go back to it's gonna go back to the sandbox in the Unreal. It's gonna show you physics running. I just put on tick here just to be, because I was lazy, but we can actually run that asynchronously. Just create another thread. We can even use async task on Unreal, or otherwise just use create our own thread system, which in case of a crash is going to be annoying, but at least we know that it's going to be that causing it. So here I just created 3 different shapes randomly, like a cube, a capsule, and a sphere. And I wrote a very simple draw, using debug draw calls of Unreal. So here now you can see, should start, yeah. And you can see that that is the test that I made. It is running physics inside Unreal 5. And I don't know why they say that it's not possible, well, it works. So basically the guys from the finals, that's what they've been working on. They replaced the entire chaos with a physics. So apart from this, let's go ahead. So everything is possible. We can do that. We can do some in real time. We can continue now. Otherwise, I would run out of time. And then we can go to the technical deep dive. For the technical deep dive, I'm going to start with mentioning some real great works from other programmers from the Epic community. First of all, the terrain deformation. If you guys have you heard about this tool? Is like a tool. It's called the Voxel Pro, and which is also there is also a free version with an open source which we can download. This guy Victor Carell made this plugin, which is available. You are free to download it, have a look. And this tool went so well that people started building games in 3 weeks. Because if you remember about this game, there was a game recently, a game about digging a hole, is using actually the Voxel Pro plugin, free version, not even the one I paid, which makes me wonder. I hope they bought it after making a lot of money. And so yeah, I recommend you to have a look at that for research if you want to know more. And then procedural debris generation. We have another guy that his name is Mika, that he built this game, which is very funny. It's like a giantess that goes around and destroys buildings. Everyone, I don't know why people like destroying things. I think it's fun. Yeah, if you haven't seen that, you should check it out, because it's really It's a very fun game, entertaining. And this guy, Mika, has been Beringhausen, has been working on this game for a while. And he's been creating those procedural destruction in Houdini. So everything's still pre-calculated. Yeah, you're free to reach out him. He's a very friendly, he's a very good, very nice guy. And he's put all his source code open source for 9.8 and Niagara. And he got a plugin. Yeah, and if he doesn't reply, just tell that I sent you, so he will understand. I recommended you, yeah. So going back to my system, I wanted to do this, the dynamic destruction. So I started working on this. I started to try to find a solution, right? And I could, let's start. Geometry script. You probably heard about geometry script. Anyone knows about geometry script here? Cool. Okay. That's awesome, because a geometry script, not many people know that. They were introduced recently in Unreal 5, and they allow the manipulation of polygons even real time. So why this plugin? This geometry script, by enabling this plugin, we can have access to dynamic mesh components and the actor. We just create a new actor. We select our dynamic mesh actor. And after doing that, we just have a new class based on the actor class. And doing this, we just get a new node that is basically with a honorable generate mesh. We can build a mesh and call other functions. Obviously, all this code is open source, so if we double click on the actor, we can see exactly what's happening inside. And yeah, in the geometry script, this is a very quick example. We just create a box and we change the width, depth, and the height. By creating a box like this, in the editor, we just drop it, make the U property visible in the editor. We can just change it, and we have a box generated in real time. Is not scaled, is generated in real time. That's the difference. By doing this, if you look deeper in the geometry script, there are a lot of functions based on that allow us to create a Boolean operations. So imagine having those, what could you do with a Boolean operation? You can get a cube and make a hole, right? Should be possible. So in this case, I think I created a Boolean mesh with I was creating a Boolean mesh. Maybe I'll go forward, it's much clearer. And I apply the Boolean operation on that. So what happens, and this is a video that I took from the Epic website. And you can see that this Boolean operation is very, happens even in real time. Well, it's a simple mesh, so there is not gonna be slow. And if you are more interested in that, if you are a level designer, if you like those things, you can even create your own tool, and you can make a button, even a button to convert the mesh into static mesh. So you can even create your own tools and to bake stuff. You create galleries in real time, they become static. You can export them, or you can do whatever you want, straight directly into Unreal without no problems. And if you are interested in geometry scripts, feel free to reach out the website of Epic. There is a really good documentation, a lot of videos and examples. You will understand a lot about how internally work the geometry scripts. So going back to continue on that, the problem about geometry scripts, they don't support nanites, mesh distance field, LOD, instance rendering. And also another important thing, all the operations are always executed on the game thread, which means that if you have a very complex geometry and you want to cut a hole or break something, it's going to take a while, and the engine might might cause a glade and a hunch. Yeah, that's slow down. Yeah, and. In the end, I managed to get a hole. I made going back to my box, I managed to make a simple hole in that brick. Made me happy, but yeah, the problem is that using those blueprints makes everything more easy for a designer to create all this work, even using blueprints. But imagine having, again, a really big mesh. What's going to happen? You know what's going to happen? This guy is going to complain and come to visit you. If you don't know him, he's the Ari, the hinge hunter. I recommend watching his video. It's very good. He also does a musical, and he is always complaining, explaining how to fix all the hinges. Going back to my destruction system, I did a bit of progress thanks to all those tutorials, and I started to write everything in C++ from scratch, and I managed to do a test, which I'm going to show you here. In this test, I haven't still shown anything publicly. You will see some particles not really working properly because some of them they are still using chaos simulation. But if you look closely, all the parts destructible, all the destruction, the damage is replicated properly on the client and server. And yeah, you can see that this is running. Can you imagine how big is that mesh? Super big. Not breaking anything there. Anyway, yeah, you can see that all those these particles, most of them are done within Niagara, but those big chunks, they are actually the Boolean operation coming out from the big mesh. So you can see you can even destroy the terrain. You can make holes. You can break the terrain with a hammer if you want. And then obviously we have our friendly Labubus there, and that they are so satisfying to destroy. Yeah, I wanted to put them. Yeah, you can see those white particles are Niagara. I still have to fix that because yeah, I didn't have time to continue on this video on this implementation, but I will. I just added support for multiple materials. You can see you can destroy the Labubu, and I'm working on the structural damage. So continuing about this, yeah, you can see that showcase. You can go there and break the hands if you want, and yeah. The part is falling not the same as the other because it's not using determinism, but it will be fixed. But if you look at the damage, it looks exactly the same on both client and server. Yeah, poor Labubu. And yeah, going forward, we need, after doing those tests, we need to think about performance strategies. Yeah, there are so many problems that we will have to handle. You're free to give it a go with the geometry script, but then you will end up in so many performance issues. Then you will start to think, oh my God, how I'm gonna fix that, I'm gonna fix that. In the end, the best solution is to use a native language like C++, but yeah, it's just my suggestion. But still, with a geometry shader, you should be able to achieve something very, very good, decent. I haven't published my code yet or plugin because I have to finish that. When I will be in a good stage, I'm gonna make it public so everyone can use it. And to continue, I left a bit of time at the end because I was not sure if how long it was going to take. And yeah, I just want to go give a bit of takeaways that using chaos alone is not enough, but I know because our friend from Epic, Chris Murphy, already told us yesterday that Epic is already working on a new version of chaos. They're gonna call it Chaos 2.0. But yeah, in the meantime, we can try to do our research, get rid of those, try to destroy everything by yourself, since they is not available to everyone. And yeah, the future direction is to use, improve everything with vector texture and chaos again, and nanite. And I really encourage you as a programmer to look for your, don't listen to anyone, just think with your own mind and try to create something that no one else has done yet. So before I continue to the QA, because I think that we have problems, I didn't know that we were gonna have a problem. I was gonna finish so quick. Since we have time, I'm gonna show you a small trick that I learned. If you want to modify Unreal Engine, what's going to happen? You have to rebuild the entire engine. But there is a small trick that I will show you now. I hope you are C++ programmer. Instead of doing that, we can just look at the code. For instance, for one of the... Can you please play the video? Thank you. For instance, I had a big problem with the collision calculation. I opened the function in Unreal Engine, and I had so much, so many functions, so many calls, which could be optimized. And I was like, oh my God, now what I'm gonna do? I'm gonna rebuild all the engine. It's gonna take ages. What if I have to change something and do that and that? What did I do here? I created a copy of the function. Don't know if you can see that. I copied the function to optimize, to calculate the collision, and I copied that back into my project, and I called the calculate collision 2. Then I did all my optimizations, and when I go back to my implementation, instead of using the Unreal Engine original function, I use the custom one, and magically works. It's a very simple trick, but I strongly recommend you because it saves so much time. You don't need to rebuild everything. You just do your own implementation. Very straightforward. And yeah, to end this talk, I can show a video of my current, of the current state of my destruction. And yeah, and then if you have questions, we can proceed. There is a video at the end. I don't know if you haven't seen this, but I'm preparing a new one. I made a video where you can destroy all those chunks. This is using 561, and I made a test build. So I was using all the advantage of performance. You can see there are too many rocks. I know I did a mistake there in the calculation, but I'm gonna fix that. You can see that you can make holes everywhere. The chunks falling apart from the particles, they are exactly the same mesh that gets removed. For the glass, don't worry about that. That's still chaos. I haven't finished that. So yeah, looks cool. This is chaos, what you can do with a chaos fraction system. But all the other parts that you can see there, all the blocks and the holes, they're all real time. You can see a bigger mountain, you just shoot, you make a tunnel. This will open so many possibilities for gameplay, because we can create a huge system with a big terrain and make holes everywhere. I don't know why no one has been thinking about that, but I think no one wants to destroy everything. It's like me. And yeah, and you can see that those are some mountains. You just shoot, and you can get all the rocks falling, stuff like that. Yeah. And I promise that I will post more videos. But yeah, this pretty much is my current state. Even if I did more upgrades, I will show you maybe next time how to do structural damage, because I'm working on that. Cool. Anyway, if we go back, if you guys have any questions, feel free to ask. Yeah. Yeah, if you have any question, please. I don't know if it was so confusing because I get very excited when I talk about this topic. So sometimes I cannot even track time. I thought I was going to finish late, but actually I finished 10 minutes early. That's pretty good. Thank you. You guys have any questions? Did you understand everything about what I said, or was too confusing? Too fast? No? Yeah.
Hi, you mentioned that, like, with the previous geometry collections, like, there's just a huge memory footprint because of all the collections you have to keep in memory. You were talking about using this dynamic system across large landscapes, and so as you continue to destroy elements of the landscape, isn't that going to increase the memory footprint?
Not. It will increase memory usage, but not much, because all the calculations after doing after destroying some objects, we can simply remove those meshes, which they could be temporary. But with a chaos, we needed to place those meshes in the world. So we will have thousands of meshes. We can just remove them, or we can even do some kind of optimization to stream them, or LOD, or yeah. There are a lot of ways to prevent that. In my test, I didn't make a video. I made a very big, very tall cube, and I made a whole vertical that was never ending and was not slowing down. I will post a video for that, so you will see what I mean.
Awesome, thank you.
Thank you. Any other questions?
What algorithm are you using to generate the booleans, I guess you're cutting out of the meshes?
Well, for those I'm using optimized Boolean operation. Can just perform a subtraction or first, and then we can get the intersection from the Boolean operation. After getting intersection, we can, if we want, we can even create multiple sub-tasks to break the original mesh. Maybe we can even create multiple blocks from the same mesh. But everything should be asynchronous. So yeah, to answer your question, is pretty much Boolean operation, but optimized. My next goal is to make them work on the GPU with a Vulkan or CUDA. Yeah.
Great, thank you.
Cool. Any other question?
Thank you. I'm an artist, so most of what you said sounds like witchcraft to me. But I am curious about how the texturing works for the inside of the meshes.
That's a good question, yeah. We can use different type of mapping for that. That could be a really good talk, actually. There is a system called the three-planar mapping that we could use for those cases. So we can mix 3 different textures based on X, Y, Z, and based on the depth, we can even blend with another texture. And this kind of system is very good because it creates very nice, realistic mapping, because it interpolates between 3 different textures. I don't know if it's clear enough, but
yeah. Just if it's okay, a follow-up question. Does it get memory chunky with triplanar textures?
No, not really, because it's gonna use the same textures. It's not generating new textures. It's just reusing the same and mapping them on the different on the UV of the broken part.
Gotcha.
Yeah.
Thank you.
Thank you. Yeah, just if you don't have any question, I just want to say I really hope that you got my message, that is not about only destroying everything, but is mostly about thinking with your own mind, your own brain. There is no real engine. There is no best engine. What we needed to do in this industry is to create something that we really want to be unique. We don't have to be dependent on whatever the industry is giving us or whatever we see on internet. So yeah, my message is to use your imagination and innovation. Prove that the impossible is possible. That's what makes us special in the gaming industry. Thank you. Thank you. Thank you.